Good afternoon, guys. So we're going to continue with our lessons on fractions. So yesterday we were talking about operations with fractions. We were focusing on adding and subtracting fractions. So the first thing we went over was adding and subtracting like fractions, which is actually really simple. Okay, so remember our definition of like fractions are any fractions that have the same denominator. Okay, so remember, denominator is our bottom number. So if the bottom numbers of your fractions are the same, they're like fractions. And then when it comes to adding or subtracting them, it's really simple. You keep the denominator the same. Okay, so whatever the denominator is of your like fractions, that's going to be the denominator of your answer. And then you just simply add or subtract the numerators. Okay, so like fractions are really easy for us to deal with. They're really friendly to deal with when we're doing operations. Okay. The other type of fraction that we were talking about was unlike fractions. Okay, so opposite to like fractions. Unlike fractions are any fractions that have different denominators. Okay, so their bottom number are not the same. Okay, unlike fractions are a little bit more involved for solving operations. The reason for that being we have to convert them to like fractions before we can do our operations. So we went through some examples with how we're going to do that for addition, and then we're going to talk about how we're going to do that for subtraction today. So it's very similar to the method for addition. The only difference is the final step is we're going to subtract instead of add. Okay, so the converting to like fractions is the same no matter you're adding or subtracting. It's just the final operation that will be different. Okay, so let's look at this first example that we have here. Subtracting unlike fractions. So you can see here we're trying to subtract 2/5 and 1/4. They're obviously not like fractions, right? They have different denominators. This one has a 5 and this one has a 4. So before we can subtract them, we have to determine a common denominator, which means we want to convert them to like fractions. So the way that we're going to do that, just like we were doing that before with our adding, right? If we go back to our examples from above, we were multiplying the numerator and the denominator of one fraction by the denominator of the other. Okay, so by doing that, we were creating these common denominators between our fractions, which let us add them without doing anything else. Okay, so we're going to do the same thing for subtracting. So you can see that they've done this here for us. They took this 2, so the numerator of 2/5, and multiplied it by the denominator of the other fraction, and they did the same thing with the 5. Okay, so you can see that here and here. They did the same thing with the 1/4, so they took the numerator of 1/4, multiplied it by 5, and then took the 4 and multiplied it by 5 as well. Okay, and we can see that here. So 1 times 5 and 4 times 5. So when you do all of that multiplication, you end up getting something that looks like this. So 2 times 4 over 5 times 4, so our 2/5 becomes 8/20, and our 1/4 becomes 5/20. Okay, so we've converted these into like fractions, which means now to solve for our subtraction, all we do is subtract the numerators. Okay, so remember the denominator does not change. So the denominator in our question is 20. So we're going to have that as our denominator in our answer as well. And we're just going to subtract our numerators. Okay, so we do 8 minus 5, and we're going to get 3 over 20. Okay, so 3 over 20, that's a simplified fraction. We can't make it any more, we can't simplify it any further. So our answer to that question would just be 3/20. Let's try some examples ourselves here, okay? So again, the first thing that we want to do with these questions is convert to like fractions. So the way that we're going to do that is by multiplying the numerator and the denominator of one fraction by the denominator of the other. So we're going to take our 4 and multiply it by the denominator of our other fraction. Okay, so we'll get 4 times 4. And we're going to do the same thing with the 5. So we're going to do 5 times the denominator, so we get 5 times 4. Okay. If we do that multiplication, we end up with 16 over 20. Okay, so 4/5 is an equivalent fraction to 16/20. Now we're going to do the same thing for the other fraction, so we'll just switch colors here so we can make it more obvious. So we're going to take the numerator of 1/4, which is this 1, multiply it by the denominator of our other fraction, so we end up with 1 times 5. And then we'll do the same thing for this denominator. So we're going to multiply 4 by this 5 as well. Okay, so we do that multiplication. 1 times 5 is just going to be 5, and then 4 times 5 is going to be 20. So 1/4 is an equivalent fraction to 5/20. Okay? So now we have two like fractions, right? They have the same denominator of 20, so we can simply add them together. So we have 16/20, and we're subtracting. So we want to subtract 5/20 from 16/20. Okay? So remember, our denominator doesn't change, so we leave it as 20. We don't subtract it, multiply it, add it. We don't do anything to our denominator. We just leave it as 20. And then we subtract the difference between our numerators. So we have 16 minus 5. That's going to give us 11. Okay, and so 11 is already simplified. We can't simplify that fraction any further. So this is going to be our answer here, 11/20. Let's try another example. So we have 5/7 and we want to subtract 3/5. So again, we can see right away these are not going to be like fractions. Okay, they're going to be unlike fractions because they don't have the same denominator. So we need to convert them first. So we're going to take the numerator of our first fraction here, multiply it by the denominator of the other fraction. So we get 5 times 5. And then we're going to take the denominator of our first fraction here and also multiply it by the denominator of the other fraction. So we get 7 times 5 for our denominator. We do that multiplication, we end up with 25 over 35. Okay, so 5/7 is an equivalent fraction to 25/35. Okay. Now we're going to do the same thing for our other fraction here. So we're going to take the numerator of this fraction, so that's going to be 3. And we're going to multiply it by the denominator of our other fraction. So we get 3 times 7. Okay. We're going to take the denominator from this fraction, so this 5, and we're going to multiply it by the denominator of the other fraction. So we get 5 times 7. So we do our multiplication. We end up with 3 times 7, which is 21, and 5 times 7, which is 35. Okay. So now we have two like fractions. They have the same denominator, so now we can just go ahead and subtract them. So we have 25/35, and we're going to subtract 21/35 from it. Okay. Remember, we leave our denominator the same. It doesn't change, so our answer is going to have a denominator of 35, and then 25 minus 21 is going to be 4. Okay. Again, this is a fraction that can't be simplified any further, so our answer is just going to be 4/35. Okay. If you rewrote this question, so our question originally, if you remember, was 5/7 minus 3/5. Okay, and we know that that equals 4/35, right? If we look at this equation like this, it's kind of hard to see why that makes sense, right? 5/7 minus 3/5, well, how does that equal 4/35? Like, none of those numbers seem to have any sort of relationship between one another. When we look at our converted fractions above, so 25/35 and 21/35, it makes a lot more sense where those numbers came from. Okay, so that's why dealing with these unlike fractions can be a little bit more confusing, but as long as you can remember to do that cross multiplication, you should get the right answer. Let's try another example. So we have 2/3 and we want to subtract 1/2 from it. Again, these are unlike fractions, right? They have different denominators. So first thing we need to do is convert them. So we're going to take the numerator of this fraction, multiply it by the denominator of the other fraction. So we get 2 times 2. And then we'll do the same thing with this denominator. So we get 3 times 2 on the bottom. Okay, so do that multiplication, you end up with 4 over 6. So 2/3 is an equivalent fraction to 4/6. And now we're going to deal with our other fraction. So we have this 1/2 here. Okay. Let's try red. Sure, let's be different. Okay, so we're going to take the numerator from this fraction, multiply it by the denominator of the other one, so we get 1 times 3. And then we have this 2, the denominator of this fraction, we'll multiply it by the 3 as well. Okay, so if we do that, we get 3 times 1 on the top, so we get 3, and 2 times 3 on the bottom, which is 6. So 1/2 is an equivalent fraction to 3/6. That's actually something that we've seen before. We've seen the relationship between those fractions before, so hopefully some of these will start to get useful, some of these will start to get familiar to you, and you'll be able to just see the relationship right off the bat. So now we have two like fractions. We have 4/6 and 3/6, so we can go ahead and subtract them. So remember that 4/6 was our 2/3, so we're going to do 4/6 minus 3/6. Okay, so we leave our denominator the same. We don't do anything with that. It doesn't change. So we leave 6 on the bottom, and then we just do 4 minus 3. So 4 minus 3 is going to be 1. So our answer is going to be 1/6. Remember that anytime your numerator is 1, your fraction is already as simplified as it can get. You can't simplify it any further, right? Because if you were going to do that, you would end up with a number that's a decimal, and we don't ever want to have decimals in fractions. Okay, let's try this last one here just for good practice. So 6/7 minus 1/2. Okay, do this the same as always. Multiply the numerator and denominator of one fraction by the denominator of the other. So we get 6 times 2 over 7 times 2. That's going to be 12 over 14. We're going to deal with the other fraction now. So we have 1 times 7 and 2 times 7. Okay, so that's going to be 7 over 14. So now we have like fractions. They have the same denominator, so we can subtract them. So we're going to do 12 over 14 minus 7 over 14. Our denominator doesn't change, so denominator stays as 14. 12 minus 7 is just 5, so our answer is going to be 5/14. Okay. Again, this is going to be a fraction that we can't simplify any further, so we're just going to leave our answer as 5/14. Okay, so that's about all we had to go over for reviewing our operations with fractions. Next thing that we want to get into is talking about mixed and improper fractions. So hopefully you guys sort of remember this a little bit from the last class that you would have taken, okay? So let's start by defining a couple of different terms that we have. So we've already talked about proper fractions before. So proper fractions are any fraction where the numerator is smaller than or equal to the denominator. Okay, so let's write some examples. So 2/3 is an example of a proper fraction. 1/2 would be an example of a proper fraction. 4 over 4 would be an example of a proper fraction. Okay, so all of these examples, our numerator is smaller than or equal to, like in this one, the denominator. Okay, so these are what we call proper fractions, and they're pretty easy for us to deal with. Improper fractions are something that we've sort of touched on before. So if you remember when we were doing our adding of like and unlike fractions, a lot of the times we were getting answers that I told you guys were called improper fractions. So an improper fraction is just any fraction in which the numerator is bigger than the denominator. Okay, so an example of an improper fraction could be 8/6, could be 11 over 4, 4 over 3. Any fraction where this number up top, so our numerator is bigger than the denominator, is going to be an improper fraction. The final type of fraction that we need to mention is called a mixed number. So it's sort of a type of fraction, okay? It's more of a term that involves a fraction. So a mixed number is a combination of a whole number and a proper fraction. So keyword proper fraction, okay? So a mixed number could look something like this. 1 and 1/2 could be 2 and 3/4, 4 and 5/8, sure. Okay, something like this. So let's say it was 2 and 4/3. This would not be this would not be a mixed number because this is not a proper fraction, right? The numerator is bigger than the denominator, so that would be an improper fraction, okay? If we remember our definition of a mixed number, it has to be a whole number and a proper fraction, okay? So this one would not be a mixed number. So mixed numbers are essentially just simplified improper fractions, okay? And I know that you guys love my pizza examples, so we have another visual here, okay? So this example is showing you how we can consider the same amount of pizza in two different ways, okay? So on the left here, we're defining this pizza using a mixed number, right? So 1 and 3/4. We have one whole pizza and then 3/4 of this other pizza, okay? Another way of talking about these two pizzas would be in an improper fraction, right? If we count up all the pizzas, or all the pieces here, sorry, we have 1, 2, 3, 4, 5, 6, 7 pieces, okay? So we have 7 over 4. So the denominator, we're still using the denominator based on the number of equally sized pieces, okay? But we're only talking about the number of equally sized pieces per one pizza, okay? So that's how our fraction becomes improper. We have 7 pieces, and we're considering that over a denominator of 4. So 7 is obviously a bigger number than 4, so this is an improper fraction. The only reason we're really concerned about improper fractions and mixed numbers is for when we want to convert our answers. So like when we were doing those addition problems and we were getting answers with improper fractions, sometimes we want to convert those to mixed numbers, okay? So how are we doing that, right? So to convert an improper fraction to a mixed number, we follow the following steps. So we divide the numerator by the denominator, okay? We write down the whole number answer, write down any remainder above the denominator. To find the remainder, multiply the whole number by the denominator, subtract the answer by the numerator in the improper fraction, and then write this value as your new numerator. Okay, so there's actually quite a few steps involved with this. So let's try and do an example here, okay? So let's just do this following our steps. So we have 11 over 4, okay? So this is an improper fraction, right? 11 is bigger than 4. So first thing we want to do according to our steps is divide the numerator by the denominator, okay? So we literally just want to type into our calculator 11 divided by 4, okay? So that's going to give us an answer of 2.75. Second step, write down the whole number answer, okay? So whole number answer, 2.75, okay? Third step here, write down any remainder above the denominator, okay? So above the denominator, so we have 2 over, our denominator is going to stay the same, okay? So our denominator is going to be 4, just like it was in our original fraction, and our remainder is this 0.75 here, okay? So look at our next step, right? So we sort of have to combine steps 3 and 4, right? So it says to find the remainder, multiply the whole number by the denominator. Okay, so the whole number is 2, and we want to multiply that by the denominator. Okay, so we're going to do 2 times 4. Okay, so we're going to consider that to be 6. Subtract the answer by the numerator in the improper fraction. Okay, so subtract the answer by the numerator in the improper fraction. Okay, so the numerator in the improper fraction is 11. So 11 minus 6 is going to give us 5. Okay, and write this value as your new numerator. Okay, so new numerator is going to be 5. So our answer is going to be 5 over 4. Okay, I'm going to be honest with you guys. Those steps did not really seem to make sense to me. I think we're going to... Oh, geez. Okay, let's skip this one for now, okay? I'm going to look back at these steps. Honestly, these are steps that I took from the previous math instructor, and to me, I think that they could be cleaned up a little bit to make a bit more sense. So before we get into doing this, let's look at converting the other way, okay? So converting mixed numbers to improper fractions is actually a lot easier than doing it the other way. Okay, and I'll show you why. So all those steps, I'm going to clean that up a little bit, and we'll have a lesson on that when we get back from reading week, because that was sort of, I didn't like how that was written out, okay? And I obviously didn't practice it before I started recording this lesson for you guys. So in the spirit of full disclosure, we're just going to skip ahead to converting mixed numbers to improper fractions, okay? Because that's a lot easier, okay? So to convert a mixed number to an improper fraction, we just have 3 steps. We're going to multiply our whole number. Okay, so the whole number, like for this example, would be 4. We're going to multiply it by the factor's denominator. Okay, so we're going to multiply it by this denominator. We're going to add that to the numerator and then write the result on top of the denominator. Okay, so let's try and do that. Okay, so we have 4. Okay, multiply the whole number by the factor's denominator. So we want to do 4 times 9. Okay, that's going to give us 36. Add that to the numerator, so 36 plus 2 is going to be 38. And then write that result on top of the denominator. So our denominator is 9. Okay, the denominator doesn't change. So we're going to write 38 over 9. Okay, so 4 and 2 ninths is equivalent to saying 38 ninths. Okay, so these are 2 equivalent fractions here. Okay. Let's try another one. So see how these are a lot simpler, right? There's just 3 steps, right? So first thing we want to do, take our whole number and multiply it by our denominator. So we're going to do 8 times 12, okay? So 8 times 12 is going to give us 96. We add that result to our numerator. So we're going to do 96 plus 7. Okay, so we get 103. Okay. And then we just put that on top of our denominator. So our denominator is 12. We don't change that. Okay, this stays the same. So our answer is going to be 103 over 12. So 8 and 7/12 is an equivalent fraction to 103 over 12. Okay. Let's try doing some more here. So we have a couple more examples. So we have 3 and 2/5. So again, let's rewrite this. So 3 and 2/5. What we want to do is multiply by that and add that. Okay, so step 1, step 2. Okay, so step 1, 3 times 5 gives us 15. Okay, we want to add the 15 to our numerator, so 15 plus 2, so we get 17. And then we just write our answer on top of our denominator. So our denominator is 5, we leave it as 5. Okay, so our answer becomes 17/5. So 3 and 2/5 is equivalent to 17 over 5. We have one more example here, so let's try this one. So 7 and 4/15. Okay, we want to multiply by this 15 first, add the 4, and then write our number. So we have 7 times 15. Okay, that's going to give us, well, let's see, 7 times 15 is going to be 105. Okay, we want to add 4, so 105 plus 4 is going to give us 109. And then finally, we just put that on top of our denominator. So our denominator here was 15. We don't change that. We just leave it the same. So we see that 7 and 4/15 is equivalent to 109/15. Okay, so our improper fractions are sort of, they look kind of ugly, right? We have these really big numbers, 109 over 15, 17 over 5, 103 over 12. Okay, so that's why we like to convert them to mixed numbers. Like I said, I'm going to go back and clean up our instructions for how we can sort of stepwise convert from improper to mixed fractions, okay? As for right now, we're just going to leave it at that. You can see that converting from mixed numbers to improper fractions is actually pretty straightforward. There's just 3 simple steps involved, okay? So you should be able to do those questions. Any questions that ask you to convert from an improper fraction to a mixed number, you can just ignore those for now. I'm not sure if there are, but if there are any on the assignment, feel free to just skip past them, and I will omit them from the assignment. I will just not mark them. If you do them and you get it right, I'll give you a bonus mark, but if you don't know how to do them, don't worry about it because we didn't end up going over it. Like I said, with tomorrow being the day before we all go on holidays for about a week, I'm expecting attendance to be a little bit quieter in the afternoon. So I'm going to find a YouTube video to play for you guys. It's going to be sort of all about this kind of fraction stuff, okay? So if you can come to class, definitely do, because those videos always help. And even if you just use that time to work on your assignments, again, I do recommend working on it sooner rather than later, just doing it while it's all fresh in your head. Reminder that if you have any questions, feel free to email me or send me a message on Teams. Can't promise how quick I'll answer you, but I will definitely get back to you at some point, okay? Nothing should be too urgent. You do have the full 2 weeks for mathletics as well as your written assignment, so don't stress about any of it over the holidays, but do make sure you try and get it done. And I'll be expecting you guys to all hand those in the Monday that we get back, okay? So as for right now, we'll leave it there, and you guys have a great weekend.